All right, let's go over some of these equations from section 6.6. So the strategies depends on what you're looking at. In part A, I'm seeing a single log, so I can go ahead and convert that to exponential form. The base is 5, the exponent is 2, and it equals x squared plus x plus 4. Now that I've done that, I'm seeing that I have a quadratic equation. So we'll see if it's factorable. If not, we'll go ahead and solve it using some other method. So 5 squared is 25. I'm going to get 0 on one side to see if I can factor. So I'll subtract 25. And looking at this, it doesn't look like it's factorable. We can go ahead and use the quadratic formula. So let's go ahead and do that. X equals -1 plus or minus the square root of 1 squared minus 4 times 1 times -21 over 2 times 1. I went ahead and put this in my calculator to get an approximation. And it's approximately equal to -5.11 and positive 4.11. So one thing you want to be aware of is that sometimes you'll get answers out that aren't necessarily solutions into the original equation. Remember that you cannot plug in negative numbers into a log. However, if you look at this number, -5.11, if you plug it in here, you do get positive 25. So I would just go ahead and just double check on that when you get answers, two different answers like that, and just make sure that neither of them is giving you a negative argument inside of your log. Okay, part B, slightly different. This is an exponential equation, but the base is e, which indicates that we should use a natural log. So I will natural log both sides. Okay, and the natural log is base e, so the natural log of e to the 2x plus 5 is 2x plus 5. Okay, now we'll go ahead and we'll solve it out, and then we'll round in the very last step. I don't want to round in too many intermediate steps because I might make the answer less exact. Okay, so I'm going to subtract 5 from both sides and then divide by 2. So x is equal to the natural log of 8 minus 5 divided by 2. When you put that in your calculator, you'll get approximately -1.460. Part C, log base 3 of 3 to the x. If you know the properties of logs, this will be extremely simple. These bases match, kind of like how we had natural log of e. Log base 3 of 3 to the x is x. So this is just x equals -1. You could do a lot more work to solve this, but if you know the properties, it's extremely easy. Part D, we're seeing another exponential equation. This time the base is 10. You do need to isolate that exponential term before you can use the logs. So your first thing you do will be divide by 2. Okay, so because the base is 10, it only makes sense to use the common log. Oops, I forgot to put the log here. Log of 5/2. Okay, so log of 10 to the 2 minus x is 2 minus x. That's why we used it, because it would cancel out. And I want to solve this for x, so I'll start off by subtracting the 2. And then divide by -1. When you divide by -1, the signs of both terms change. And then you can go ahead and put this in your calculator, and you get approximately 1.602. Okay, so this one, you can see there's 2 logs. Luckily, they have the same base. So what we want to do is move those factors up as exponents. So this is log base 5 of x squared, and this is log base 5 of 4 cubed. So if log base 5 of something equals log base 5 of something, those two arguments must be equal. So x squared equals 4 to the third. So x squared equals 64. So x equals plus or minus 8. However, if you look back in the original problem, we could not plug in negative 8. So really the only answer is positive 8. Okay, one more here. I want to use the properties of logs to contract these two separate logs into a single log. I'm seeing addition, so I can combine them together as a product. So I would have log base 6 of x plus 4 times x plus 3 equals 1. The point of doing that is now that I'm seeing a single log, I can convert it to exponential form. The base is 6, the exponent is 1, and it equals to x plus 4 times x plus 3. So this will be a quadratic equation. Let's FOIL it out. Let's see, we get, would that be 7x plus 12? And if we move the 6 over, get 0 on one side, this one will maybe be factorable. If not, we can use quadratic formula. It looks like this one happens to be factorable, so let's go ahead and factor it. And we will get two solutions, but they may not both work for the original problem. So I'm getting x equals negative 6 and x equals negative 1. But if you look at these original arguments, x plus 4, x plus 3, I would not be able to plug in negative 6 into those. Those would give me negative numbers inside the log, which is undefined. So there's really only one solution, x equals negative 1. I want to add a problem onto here just because there isn't one like it. Let's say you had something like this. Let's see, what can I say? 2 to the x plus 1 equals 5 to the negative 2x. In an equation like this, I'm seeing two exponentials with different bases. So you will still need to use a log. It doesn't matter which one you use. You can use natural log or common log. I recommend one of those because obviously those are in your calculator. I tend to use natural log just because it's fewer letters. Okay, the reason you want to use a log is you can use the property to now bring these down to the front as factors. X plus 1 is a binomial, so you do need parentheses around it. It's a binomial factor, x plus 1 times natural log of 2 equals negative 2x times the natural log of 5. So I want to solve for x. I'm seeing x's on both sides. This can get kind of complicated. What I would recommend doing is to just distribute this natural log of 2. That way we can get rid of these parentheses on the left-hand side. So I have x times ln of 2 plus ln of 2 equals negative 2x times ln of 5. Now, if I get these terms together that have factors of x, I could potentially factor them out, or factor out the x. So I'm going to subtract x ln 2 from both sides. This gives me both of the x terms on the same side. So I'm seeing that both of these terms contain a factor of x, which means I can factor it out. This is pretty much the only way to isolate x in this case. So I'd be left with negative 2 ln of 5 minus ln of 2. So the last step to isolating x and getting an exact answer would be to divide both sides by this giant factor in parentheses. So I have natural log of 2 divided by negative 2 natural log of 5 minus natural log of 2. So that is the exact answer for x. Let me go ahead and type that into my calculator to get an approximation. ln of 2 divided by negative 2 ln of 5 minus ln of 2. So x is approximately equal to negative 0.1772.